That's it. Recording is ongoing, so let's start. Welcome, everyone. Welcome to this software craftsmanship new talk. Today, we are welcoming, well, you know who, one of our co-hosts here, Guillaume Faas from SCL. He's working at Vonage. So far, so good. And yeah, today is going to present something about the exceptions and alternatives you could use to avoid using exceptions in your code. If you have a few words to present yourself, Guillaume, what would you say to them?
Well, that's a little bit weird to be on this side of the table this time. So obviously, normally most of you should know who I am. So my name is Guillaume. As Tinel just said, I'm a .NET developer advocate at Vonage, and I'm also one of the organizers of the meetup. So yeah, pretty convenient. And yeah, I think that's it for the moment. I'll go a bit deeper later on. So what do I do? Can I start or
Yeah, you know
let me
what?
share my screen for a second.
The mic is yours.
Mic is mine. All right. So you see my screen, everything's all right?
Yep, seems good.
Yep. Cool. So welcome everyone, and thank you, Gina, thank you, Arthur, for letting me speak today and for the opportunity. So yeah, a bit weird, but yeah. Just saying I don't have a view on the chat on my end. So, okay, I'm trying. There, should be all right. So we're going to talk about exceptions today, but it's going to be like a pretty technical heavy session. We're going to have a lot of code to talk about. All the snippets will be in C#, right? So if you don't do C# development usually, that would be all right, because we're not going to use any of the like very fancy features from C#. It's going to be very similar to TypeScript or anything. So yeah, just let me know in the chat if you handled exceptions already in your career. Let me know. Just say yay if you handled exceptions before. I assume most of you, or
of course,
not all. Sorry.
Of course.
You never know. Normally, most people. Yeah, most of them. That's cool. So just before we started, so who am I? That's a big question. So as I just said, I'm .NET developer advocate, and here you can have my, this is where you can find me actually. So you have my GitHub account if you want to look at what I usually do. You have my LinkedIn account if you want to connect and talk about things. I'm always available if you want to discuss. There is an additional GitHub account right there from Les Tontons Crafters. It's an organization recreated with someone you may know, Johan Thirion, the previous owner of the meetup. It's just a way for us to share knowledge, kata, workshops, and free content. Everything is open source, so take a look. And yeah, of course, the meetup itself. You don't see me usually because I'm only available for the lunchtime slot. So yeah, I'm doing my best. So, not working. There. Let me try again. Yeah, that's better. So exceptions, what the fuss? Why do I want to talk about exceptions? Well, the good thing already is most of you know what exceptions are. I just want to go back to that very quickly. This is the description from the Microsoft documentation. And they say that exceptions are a way to handle unexpected and exceptional situations. And I agree with that. And they provide actually a code snippet with that, where they show how they want to handle a division by zero. So they have a method called save division. And if you try to divide by zero, they throw an exception that will be caught later on in a try-catch block, where they can actually give a secondary behavior if the process failed. Now, the thing is, I already have a few things to tell about that. Is there any test-driven development practitioner in the room? So let me know in the chat. I can have a look. I have a question for you. So if you were to test drive the code on the right, we agree you would expect the divide by zero exception in your test. You would expect that. You would have a test that expect that safe division 10-0 would throw something. So how is it unexpected? That's a bit weird for me. Because basically every exception that you throw yourself is expected because you put it there. You put it there in the first place. So that's a bit weird. And also they say it's exceptional. What we test here is basically a user input. If I provide 10-0, I'm responsible for putting 0 over there. A wrong user input is not exceptional. It's completely the opposite. It's fairly common. So yeah, I'm not very happy with the example they use because it's like, yeah, not the right situation to show why you should use exceptions. So why do we use them? Well, they're fairly easy to use. You just throw and bam, it throws. And you can easily short circuit a process. Everything after an exception will not be executed. And important thing, they can carry a lot of information. So for example, the type. So if I tell you null reference exceptions, you know what happened. It's $1 billion mistake. If I say not implemented exception, you know what happened as well. So the type itself is already telling you what happened and probably why. And they can also carry content. So they will carry everything from the mother exception class, and they can also carry specific content. What you see on the right is the content of the file not found exception. So you also have, for example, file name and fusion log that are very specific to this particular context. So that's pretty handy. Of course, you can make your own and you can customize it the way you want. So you can carry literally anything inside. And you will see them in various language and framework. And you know, most of you already know what it is and handled them in the past. So yeah, you know what they are. So I guess we can say they're perfect and we can use them everywhere all the time. No, obviously not. So actually, they come with a various set of drawbacks. And actually, when I ask people what is the main drawback or problem with exception, people tend to say performance, which is wrong, actually. There is a cost of throwing and catching an exception, but it's very minimal, unless you're working in either IoT or like a very high computing algorithm, you will not be able to tell the difference. So performance should not drive your decision on whether throw or not an exception. The biggest problem I see, and that's a bit personal, but yeah, it's they are unpredictable. Basically, the lack of transparency. We have here an example with an interface that offer a divide method, similar to the one we had before in the example from Microsoft. Can you tell what happens if I call divide 10-0? There is only one answer to that, and the answer is you don't know. You don't know because this is an interface, and you do not know how it has been implemented behind. So for whatever reason, someone may return a default value like 0 or whatever error code they want to return, or they can throw an exception. But in that case, what exception do they throw? Is it a custom one? Is it a built-in one? Is it the global one? You have no idea. And actually, I have a funny story about that, because when I joined Vonage last year, like everyone here, I had to pass a technical interview. How surprising. And the exercise was to use Vonage's APIs, using Vonage's .NET SDK, and try to build something with it. So not very difficult. And at some point, I was supposed to create what they call an application. Don't really care what it is. Please notice also there is a typo in the method name, but we don't really care about that. But basically, when I want to create an application, I receive from that an asynchronous application. The thing is, creating an application is basically an HTTP request. So by design, it can fail, right? But I don't know what happens when it fails. From my end, what I want to do is create an application, and I want to respond accordingly depending on the reason it fails. So I know it will throw exceptions, but I don't know what to expect. And I don't want to catch the global exception type because it's a bad practice. So I do what I think most of us would have done. I look at the code, and what a terrible mistake. Basically, I see a method with a big try-catch block that calls another method with a big try-catch block, et cetera, et cetera, et cetera. So it's all you expect. Spaghetti code, meatballs, Parmigiano, the whole dish. So it's literally a waste of time. So I go back and I try a different approach. I try actually to brute force my way into the API. And so for that, I try to provide null requests. I try to provide very bad values, incorrect values, I mean. I try to call the API without network. I try to call the API with the wrong URL. And oh boy, I receive plenty of different exceptions, some custom, some built-in, and it's literally a mess. And my point is, it shouldn't be so hard to know just, all I want to do is, I want to know what to expect. And I can't do that, and it ended up being a very frustrating situation. And what I put there is basically that the signature is lying to us because it doesn't tell me what happens when it fails. And I think for me, this is the biggest drawback when we talk about exception. But yeah, it doesn't stop here, unfortunately. Another big problem I see is it's very intrusive because as soon as you throw an exception, anyone that will use your code will be requested to use a try-catch block because otherwise your exception will break its application and nobody wants that, I think. So every time you do that, someone will have to use a try-catch block, which means at least 6 additional lines of code on this side every single time. So yeah, you got to catch them all, and that's a big thing, especially on a big code base where you have a lot of exceptions. That's not very easy, and it doesn't stop there. Here is a dependency graph, completely random. So let's pretend just for a second that this dependency graph is already easy to understand, which is not the case right now. You are at the root level, and you end up with an exception. Do you know where it happened? It could be literally anywhere. So I agree with you. We may find this information in the stack trace. That is correct, but I doubt the stack trace will be useful at runtime. And actually, the location exactly where it broke, it doesn't really matter. My concern is, what is the current state of the system? Is it broken, or has it been remediated in the meantime? When the exception was thrown, was it already handled, or do I have to do it? What information do I have to put back the system in the correct state? Answers are, you don't know, you don't know, you don't know, you don't know. The only way to know is to read the whole code base, and I tried. That's not a good idea. So it makes the flow very hard to understand. And actually, a lot of people are using, exceptions for flow control. But the problem is, it brings back a little memory. So you remember go-tos, everybody complained about go-tos. They are kind of similar. They are sophisticated go-tos in a way because they can carry information also, and they can go only in one direction, but they follow the same principle, and it's like very difficult to follow when you have a lot of them. Now for the following, I can't really blame exceptions for that, but it's more what I've seen people do with exceptions. And the first part is they are overused, especially, and this is where I see them the most, in validation. And for me, that's a bit overkill. Like, throwing an exception because someone provided 0 as an input is very overkill. It's like going to an ATM, typing the wrong code, and then no more ATM because you had one try and you broke the system because there is an exception, argument null exception, or invalid code exception. And that's, this is not how it should have been done in the first place. And also, there is something I call exception paranoia. Because when you code daily on a solution that relies a lot on exceptions, every time that you call something, every method you call, you will ask yourself, does it throw an exception? And what happens? Just in case, I'll add a try-catch block. So you end up in two scenarios. Either you have plenty of try-catch blocks everywhere in the code base, or you have massive try-catch blocks. You know, the one that are like 200 lines long, and that defeating the purpose of try-catch blocks in the first place. So yeah, I see a lot of problems with exceptions, and for me, that's a personal perspective. Problems outweigh the benefits. But where do we go from there? Because it's easy to tell all that, but what do we do? Because we can't just, you know, not use exceptions or not return errors. So yeah. So I have a solution, obviously, otherwise the talk would have been finished by now and be boring and useless. I just have one slight problem. I can't tell you what it is because the name is forbidden. If I say the name right now, I may lose half the audience. I don't want to risk it. So what we're going to do is we're going to start with a small example, and we're going to build upon it until we tackle the real thing. And so in order to do that, I will use a very easy example from quantum mechanics. Relax, it will be all right. Let me know in the chat, have you heard about Schrödinger's cat before? I assume most of you know what it is. So it's a principle from quantum mechanics that states that basically, so Schrödinger has a cat, and he has a box, and he put the cat into the box. The thing is, the box has mechanism that can release deadly poison at any time without you knowing it was released, right? So what Schrödinger said is, for him, as soon as the cat is in the box, the only way for him to know if the cat is dead or alive is to open the box again. What a genius, right? Joking aside, especially in quantum mechanics, what it means is until you can observe something, you have to speculate on the fact that it can have multiple states at the same time. So what if we try to code this one? If you want a more down-to-earth example, this is, you know, like more realistic representation of what Schrödinger's cat is about. So in that case, you do not open the box, right? So this is where we have a little bit of code. So how do you create the box in the first place? Well, I'm going to guide you through it. Here you have a static factory method called with a live cat, and we see it takes cat as a parameter. So cat is just a struct, so it's not nullable. So here we need to have an instance. It is mandatory. And if you look at the top, we have a field cat that is of type cat nullable. So we understand something already here. We provide an alive cat and it's an instance, but cat can be nullable. So we understand already that an instance means alive and null means dead. It's going to be a fun talk. Yeah, trust me about that. So what can we do with this box once the cat is inside? This is where I was a bit creative. I want to shake the box. So the cat is not very happy. Yeah, so what does it do? The cat meow. Now the thing is, if you look at it, after this .cat here, you see a question mark. This is called the null propagation operator. It means that meow will be called only if the cat is as an instant, if it's not null, right? If it's null, nothing happens. And actually that makes sense, because last time I checked, a dead cat doesn't meow. So yeah. And what does meow do? Actually, meow just logs meow in the console. So yeah, if I shake, I should see meow in the console. Then you can also shake again, but a bit too hard, and then so the cat still meow because it's still not very happy with it. But then you release the poison and you kill the cat, and you are like a horrible person, because then we return an empty box with basically a null cat inside. So you kill the cat, and finally you can open the box, and then you can see you retrieve a nullable cat. This is the only way for you to see if the cat is dead or alive, because otherwise you have nothing public that lets you know or ask what is the state of the cat. So let's see that in action. First example, so I have the box with a cat inside, and I shake, and no, the cat doesn't shake his booty. We see meow, meow, meow 3 times in the console. So far, so good. If I do cat.shake, shake too hard, .shake again, we see only meow twice, because on the second shake, we killed the cat, and on the third one, the cat is dead. Nothing happens. And on the last one, not really interesting regarding the console, but more about the fact that the tests are passing instead, because this is where we try to find out what happens when we open the box. And so null means dead and alive means instance. If you're not familiar with it, you can see on the last two that I'm using openbox.should. This is fluent assertion. So it just verifies that basically openbox value should be equal with what's in the B. So in my case, it's either null or get a live cat. I want you to pay attention for a second here on two things, and keep an eye on that for the next few slides. The first thing is you don't see any branching in the code, right? If you take the second snippet, whether the cat is dead or alive, the process, the flow are exactly the same, right? And the other thing is in order to write something on the console or to kill the cat, we never manipulate the cat directly, we manipulate the box instead, right? So keep an eye on that for the next few slides. You'll see it will happen often. Now, the thing is, that's a very fun example, but it's completely useless. I mean, if you want to tell to your client that you want to implement a box that can kill a cat in his financial system, let me know. I would like to be here in the call and see his reaction. But luckily, the thing is, cat is just a struct. So we could replace cat by literally anything else, because in C# we have generics. So we could turn that into a box of tea, not the beverage, tea as generic type. So we had before like null and instance. We could turn that around and say we have nothing and we have something, right? So let's try and see what are the main differences. The main difference right now is nobody dies anymore. That's definitely a plus for me. So you can still create a box with a value inside. You can create an empty box as well. But mostly the biggest change we have is, well, there is no point shaking anymore. Why would you like to shake a date time, shake an integer? No more shaking. Instead, there is map function. And this map function takes a function as a parameter. Ooh, I said functions twice. Relax, it will be all right. So basically, we apply the same principle here. We give a function to map, and what happens is map will apply the function on the value only if we had a value in the box. If we had nothing, nothing will happen. Okay? Here's an illustration. First case, we have a value in the box. What happens is when we call map, we open the box and we take the value, you apply the function to the value, and you put the value into a new box and you pass it around. Second scenario, the box is empty. Nothing happens. Nothing to do. Let's see that in more tests, right? First case, we have a box with the value 3 inside. So I call map and I have value lambda value +1. This, if you're not used to it, is called a lambda expression. So value is basically the parameter, and everything after the lambda sign is what we're going to return. So basically, it's just an increment. So we're going to do sum3 increment, increment, increment. So what happened is I have 3 in the box, open the box, take 3, increment becomes 4, put it back in the box, 4 becomes 5, 5 becomes 6, and open box should be 6. And if we have nothing in the box, well, you can increment as much as you want. Yeah, there is nothing in the box and nothing to do. So it remains null. If you want to do the same stuff without the box, this is what it looks like. So keep in mind what I said before. Same flow, whether we have a value or not a value, and no branching, right? And we don't manipulate the value. It's getting better. I mean, this looks like something that could be usable. I just have one major problem on my end. I hate null in general. This is $1 billion mistake, and I hate null checks. So yeah, what can we do about it? How do you represent the absence of value with a value? The answer is you don't. You cannot do that. So what is our option? Here comes a method called match. Now, match doesn't take one, but it takes two functions as a parameter. Yeah, relax. It's easier than it looks. The main problem here comes from C# because it's very verbose with generics. But basically, we'll have one function for each state of our box. One is we have a value, one is we don't have a value. And what happens is we'll call the right function depending on the state. Let's try it again. So here, same code than before. And with match, I provide two solutions. If I have something I want to receive, the value is sum with the value. And if I don't have anything, I want to return the value is none. You can consider the second method as a fallback mechanism if we don't have anything. And as you can see, it works. It works. And I don't have null anymore. Suddenly, I'm very happy, but we can still go a bit further. Yeah. Let's look at, for example, everything we have under map and match. As we said before, they are functions, right? So all you have to do, you select the code, and if you're using, for example, a writer, Control-R-M, extract method, and put names on it. So value lambda value +1 becomes increment value, value is sum becomes convert to message, and value is none becomes get default message. Suddenly, we have that. And now I'm very happy. Here comes declarative writing. Suddenly, we have been obfuscating all the details of our logic there. And suddenly the code is telling a story. So when you look at that, you're reading what's happening, right? You can show that to someone who's like a junior or maybe like even a non-developer. They will probably understand if they know what map and match are doing, right? So overall, this increases a lot the way we read the flow and we understand the flow. Because when you look at that, the why and the what matters more than the how. So if I want to see how you increment something, I can then look at the method and see the details. But right now, I don't need that. I just need to know what's happening. So here you see again that whether you have a value or not, the flow is the same. It's not a coincidence, obviously, as you can imagine, and it actually has name, and someone know from the comments. So well done, Nicolas. It has a name, and it's called railway-oriented programming. Ta-da! What this means is, so you have different way to handle errors, and this is like a functional way to handle errors. So you have one green railway that represents a success state, and one red railway that represents a failure. And on the green one, we have three methods. So it's a workflow that requires you to validate some values, update the DB, and then send an email for confirmation. So what we understand is there is some kind of precedence. Sending an email depends on the success of updating the DB, and updating the DB depends on the success of the validation process, right? And what we've done so far with the box is if you go and validate fails, you end up on the red railway and you don't update the DB, you don't send an email anymore. So you still have some kind of branching, but it's basically encapsulated inside the box, and it makes your flow much easier to understand. And you still have this kind of precedence and basically sequence of things. Note that you can have more than two railways, and we'll see that later on. So now it's time for the big reveal. I don't have any drum roll, otherwise I would have, but basically the box is a monad. So now I said the name. I'm looking at the attendees to see if someone is leaving or not. But yeah. So ultimately, a monad is just a data structure that allows you to manipulate the data and underneath data and to have multiple states at the same time. That's a very simple way to describe it. This is not the official definition, but it works for me. And there is a quote from Douglas Crockford that I really love. He says that as soon as you know what a monad is, you lose the ability to explain it. So I'm trying real hard to show you that. And so monads are kind of a curse because of that. And also because as soon as you know what they are, you tend to see them everywhere. And the truth is, they are everywhere. And I'm not paranoid. I will show you that later on. So we've been creating our own monad with a box, etc., etc. But you don't have to do that, because there are actually libraries to help you do that. The most famous one is LanguageX, and it's my favorite. You have fluent results, you have Fsharp functional extensions from Vladimir Korikov, which was in the meetup, I think, last year or 2 years ago. You have the one-off, and they all come with plenty of options for your monads. And the one we've seen before, the one that we've made, is basically the option one, or the maybe, depending on which library you're using. But it's basically an optional value. And as you can see on the right, I put some example, and it's always a matter of multiple states: none versus some, exception versus success, failure versus success, or left versus right, and one-off is a bit one of a kind. So we'll leave this one around. So I want to show you how we could rewrite the first example we've seen from Microsoft using monads from LanguageX. This is with what we call a try. So a try monad is a monad that can represent either a value or an exception. In our case, we have try of value divided by divisor, and in that case, we have either the decimal or the exception itself. So if you're used to that with fluent assertion, there are some extensions used around here. But basically, divide 50 by 0, return an exception state, right? Then I could do should be failure, and then I basically have the exception I can play with. So exception, which message should be attempted to divide by 0. And if I do 50 divided by 2, I should have 25. Still, I'm not a big fan of this one, because basically what happened inside the monad, there is a try catch that catches the exception, and then you can play with the exception. I'm not a big fan of exceptions if you followed up until now. So what other options do we have? Either this is a very nice one. What happened here is we have what we call two states, left and right, and they can be of any types. So they are basically generics. So I created a record called error with a message, and if the divisor is 0, I return an error with the explanation, and otherwise I return the value. And then I just have to verify if my result is either left with the error or right with the value. Okay? Now, just for a side-by-side comparison, you see here the difference, and I highlighted in purple the number of lines of code it takes to process the value, log the value in the console. We move from 9 lines of code on the left to 2 lines of code on the right, and it does exactly the same thing. So we see something here. The code base is drastically smaller. And this is just one method and one example. Imagine on the scale of a code base. Another thing that monads can offer, and this is not something people usually talk at the first place, it's called parse don't validate. So if you came before in this meetup, we had a few months ago Nicola Carlo, who presented this talk called Types at the Edge of a System. He was talking about that. And here the idea is don't validate anymore. It doesn't mean do not process value validation, but do parsing instead of validation. Parsing is just a way to structure, transform less structured input into a more structured output. So here, for example, we have a class or struct or whatever it is called account key, right? And you cannot create an account key except by using this parse factory method. The constructor is private. You can't do anything with it. You have to go through parse, and parse contains a validation. What it means is, if you come across an instance of account key in your system, you know it is valid, because otherwise it couldn't have been created, right? If you think about validation, what usually happens is you construct an object and then you validate it, but it means that it's a two-step workflow. And in the meantime, you created an invalid object that you validate afterwards. What if you forgot to validate it? you suddenly have an invalid object hanging around your system. And it creates another problem. You have calls to validation everywhere in your system. Every time you want to use it, you're going to verify, what if it's invalid? I'm going to put some more validation in there. This is pretty simple. So if you think about it, you put that at the edges of your system, and everything that goes in. We have a great moderator over there. Thank you, Tinel. So if you put that at the edges of your system and you basically parse everything that goes in, your domain, your internal logic is suddenly very validation free, and you just have to use elements. And that's great. So overall, I believe that monads are really awesome, and they bring a lot of things on the table. So the first one I want to mention is referential transparency. So, I mean, it's more than just being transparent. This means that you can replace a method by its result every single time. If we see on the first example that it comes from Microsoft example, it's not really transparent, because sometimes div will throw an exception. You will not always receive a decimal. On the contrary, at the bottom, save division there, well, you know, just by seeing the method signature that it can fail. There's a possibility that things go south, and in that case, you know that you will have a string to explain what happened. It helps a lot in terms of reading the code and understanding the code, and especially the flow. There's also less branching. We've seen that with railway-oriented programming. That's a great perk. You don't have to think about all the things when you are reading the flow. If you've read before the book from Mark Seaman called Code That Fits in Your Head, it's basically a way here to have less things to memorize. You just read the flow and you see what's going on. And it also encourages declarative writing, because we focus a lot on functions. Now, I know this is not purely for monad, but it just go well together. So let's use it. And this one is a bit controversial, because I see that as a great perk, but some people might disagree. It forces you to deal with every possible scenario. So it means you cannot have an equivalent of an empty try catch over here. You know, so if something goes wrong, I think we should take care of it. And I think this is good, because then everything is very explicit. So I like that. Now, all of this is great, but it's not why you would like to use Monad in the first place. Actually, those features, we don't really care about them when you develop. What you care about is all the positive side effects. The code is more readable, more predictable, more maintainable. Isn't it what we all thrive for? Writing clean code, reducing the cognitive load, having smaller code base. All of these are boxes I want to tick as often as possible, you know. So moving forward, now that we talked about monads a little bit, we need to talk about a little thing. Functional programming. So just relax. We are not going to dive into category theory. We're not going to talk about math. I'm not a genius. I'm not a mathematician. I'm just a developer, just like all of you. And it's actually not that hard. If I can do it, you all can do it without a doubt. Because the main problem with functional is it looks very complicated. I mean, look at those terms. It's, yeah, no comment. But the thing is, they are very complex terms to explain sometimes easy things, easy concept that you may be already using or you may understand already. So I think you're just unfamiliar maybe with them, right? And I'm going to prove it to you. So this is, if you've been on the meetup before as well, I think Simon Painter last time was covering a little bit of that as well. So on my end, I will show you that. Here's a list with all the players from the top 10 players from last year's Ballon d'Or. So I'm a football fan. What can I do about it? Please don't judge me. But basically, yeah, you have a list there. And here's function, a code that takes the top 3 and that displays them in an array in the right order. we all agree this code is like ugly as hell, right? But the thing is, you might come across similar piece of code in your production code base, because I mean, we all have seen before for each with an if inside. And actually, there is even something my IDE is telling me there under for each. It's telling me do something because this is not good. So what can we do with that? Have you ever heard about LinkQ? Yeah, LinkQ was released in 2007 with .NET 3.5. It was released before I started my professional career, and I have gray hair. So this should give you a pretty good idea. So yeah, and the thing is, LinkQ is very, very functional, and I'm going to show you that step by step, right? So first, we have order by and select. They take functions we've seen before, player lambda player.rank. We just transform the content to now an integer. If you don't trust me, here's a signature from Microsoft documentation. Do not pay attention to the first parameter because it's an extension method, right? So but the second one is always function of t source to t result, right? And this is a name. They are called higher order functions. A higher order function is just a function that takes a function as a parameter, or return the functions, or do both. It's just a scary name for something very simple. Yeah. And if we look at this one, for example, now, player lambda player.getDisplayName. So we transform a player to a string. It's a pure function. A pure function solely depends on the input to produce an output. So it means no side effects. It means no access to static resources or external dependencies. And it may look simple, but actually, when you think about it, it's actually great because it makes them very deterministic, which means very easy to test. We all love that, don't we? And it's not over. Order by, take, and select here, they have something in common. When I do top 10 players.order by, I received an I order enumerable, but I do not change the value of top 10 players. I get a new list. Same goes for take. Same goes for select. Yeah, because it doesn't change the source list. Immutability is a very important principle. And actually, you know, if you're using the latest version of Fsharp, you may have been using record type as well. They are awesome. You should use them, by the way. And you want to know the best part about that? You used Monads before. I bet if you've been playing with Fsharp before, I'm 100% sure you've been writing asynchronous piece of code because everything is asynchronous nowadays. Well, task is a monad. Think about it. You have a task of t result, a box with a t result inside. And you can call continue with on this box and provide a new function to transform the value inside. Think about it. You manipulate the box, you don't manipulate the value anymore. That's interesting, doesn't it? Same goes for enumerable with select many. So you see, it's not that hard actually to grasp some of those concepts. And finally, closing up with the functional stuff. This is our final implementation, if I should say, on Fsharp. Look at the equivalent in Fsharp on the right. Look how similar it is, how close it is. What's amazing for me is to know that you can write this piece of code in Fsharp and you are this close to write code into a separated language, in a separated paradigm. I think it's awesome. And when I see that, there's no reason not to try Fsharp in the future, right? So yeah. Now let's see how I use Monads in my day-to-day work, because now you might say, yeah, but this is just like, it doesn't work, it couldn't work in my environment because my environment is too complex, or this is like a kata or something. I'm using that on a daily basis, and I will show you how. So first, what do we do at Vonage? Well, Vonage offers communication APIs. So whether you want to send a text message or a WhatsApp message, or you want to start a video call, send voice messages, do meetings, or two-factor authentication, there's so many APIs. I lost track of them. But we offer all that. And APIs means that you can just do everything with a simple HTTP request, right? Now, the thing is, if you played with that before, it's very boring to play with HTTP requests because you have to create the request, send it to, prepare it with the body and etc., send it to a client, get the response, treat the response code, deserialize the content, blah, 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 blah. And nobody wants to do that. So we integrate something in the middle to facilitate your life, actually. And it's a library. It's an SDK that is available in, it's a NuGet package that you can include in your system. And the best part of that is it's open source. It's free. So you can look at my code, you can contribute, you can complain, you can find some inspiration or, whatever you want to do. It's all open. So now comes the fun part. How do I use that in my flow? So remember, my goal is to facilitate the use of our APIs. So first thing I get is a user input. What do I do with the user input? I parse it, which leads me to two potential results, either a valid request or a parsing failure. Then when I have the request, I convert it to an HTTP request, and then I can send it to a good old, HTTP client. And then I get a response. So it's either a valid status code or an invalid status code, and then I need to deserialize the response, and it can either fail or succeed. Fairly simple. Actually, funny story, Arthur, which is in the call right now, always makes fun of me because he said that my work is basically to write a parser. He's right, but please, come on. Thank you, Arthur.
It's a nice parser.
Yeah, I know. Now, you remember when I said that I'm not paranoid and things? Do you see right now the railways? Because I do. You see? So now let's see how we can do that step by step. So now it's time to buckle up because it's going to be kind of the code-heavy part of the talk. So first, I parse the input. This is an example from our two-factor authentication API, and here is the state where the stage where someone requested a two-factor authentication, received the code, and need to fill the code to be able to authenticate and go through with the process. So the first thing I do is create a request. So I get a result of T request. In that case, a verify code request. And it can be of two states, request itself or failure, as we saw before. Then I convert it to an HTTP request. So here I don't put the entire method. It's a bit boring, but it's just converting the object request to an HTTP request message and add authentication and the user agent. That's it. But then, as you can see, the result type, the type of the monad is also changing again, right? Then I send it over a client, and I get a result of HTTP response message. And after that, I need to extract some data from the response because I only care about three things: the status code that will be used for logging purposes, whether it's a success or a failure, and then the content of the response. And then come the part where it's a bit more difficult, because the thing is, there was some kind of a lie on the previous diagram, because actually, when you do an HTTP call and you receive something invalid, you're still basically on the green railway because you have to evaluate whether your response has been a success or a failure. And here it comes. So I have basically four scenarios here. Either it is a success status code or is it a failure status code? In both cases, I need to deserialize what's inside. And both deserialization can fail. So I end up with four railways, one success and three failures. This is why I have some kind of branching here. So yeah, I had to do that. But otherwise, it's pretty much it. And then I cover everything. So from the caller perspective, this is what's happening. You have the request, you bind it to a verify code method, and then you call match to evaluate the response and do something with it. It's as simple as that. Now, a question I get a lot is yeah, what if I don't want to use your monads, and what if I want to throw exceptions like the good old-fashioned way? Here it comes. You can do that. I actually put on the monads, I implemented a method called get success and save. It will either return the success state. So in that case, I have a result of int, and it will return an integer if it's a success. And if it's a failure, it will throw the exception with the according type. Right. So you can do that. Because, you know, for example, I mentioned before that exceptions are kind of intrusive. Yeah, monads too. What can I do about it? You have to deal with all possible states in your code now. So yeah. And if you want here, because I'm basically having a try catch with the global exception type. If you want to do that with every possible exception, the same way you would do with a normal scenario, here you go. So pick your poison, pick your solution, but it's possible. Now it's time to kind of take a step back, because can we really get rid of all exception? Is it realistic? You know, is it even possible? So the thing is, just like good old Thanos over here, exceptions are inevitable. They are like a real part of your language and frameworks. You just can't do without them. And even if you want to write exception-free code, stuff you use like libraries or dependency, that will throw exception as well. So you can't do without them, right? And actually, even Thanos got defeated by an exception. So yeah, let's look at a real scenario. So this is an hexagonal architecture, but it works as well with other domain-centric architectures like Clean or Onion, whatever. So you have your domain, which is supposed to be pure with all the business logic. On the left, you have what we call driving adapters. They will be the entry point of your application. So console app, desktop apps, API, web application, service, whatever. And on the right, you have what we call driven adapters. They are your external dependencies. They will be APIs, database, file system, devices, anything outside of your control, right? But the thing is, they will throw a lot of exceptions, right? File not found exceptions, DB update exception. I love this one. This is a specific one from Entity Framework. Now, the question that you need to ask yourself, if I try to save something in a database and suddenly my adapter throws an exception because there is some kind of concurrency or whatever, what do I do with the exception? Do I let this exception propagate through my domain, which is supposed to be, you know, dependency free and stuff, until my presentation layer? I'm not a big fan of that. But what you can say is actually in my adapter, no exception inside. So I might have exception on the right side on the dependencies, but my adapter is basically like a firewall and it doesn't let any exception goes in. It will return monads instead. And suddenly you have exception-free domain, right? So that's a possibility. And this is where I think you need to try and experiment a little bit to see what you can do. So why did I want to do this talk in the first place? Obviously talking about monads and railway-oriented programming, for sure. But the main idea was to basically give you another tool for your developer toolbox. Along our careers, we all build our own toolboxes with best practices, methodologies, ideas, tools, etc., etc., etc. And the thing is, the more tools you have in there, the more able you are to take good decisions on a project, on your code base, on your day-to-day basis, right? Now, should you throw exceptions or use monads? It doesn't matter. It doesn't matter. We've been here for almost an hour, and I just lied to you, didn't I? No, I didn't lie. But we need to take a step back for that, because we work in a complex field, right? The only absolute answer in our job is it depends. It depends on the context, it depends on the project, it depends on the team, it depends on always something. And I want to highlight a quote from Mark Seaman here, which is one of my heroes. I was able to meet him last year a few times. And he was talking about common query separation. It's a very important OOP principle. And he basically said that sometime he was violating the principle willingly, but when he was doing that, he was not, he knew he was making a trade-off. And so it was always a big challenge to decide what to do. And take this quote, replace decide to break CQS by use exception or use a monad. And it's exactly the same. What matters is when you pick something, you need to know what you're doing. You need to know why you're doing it. You need to know what compromise, what trade-off you're making along the way. And you need to be able to explain that and defend your ideas, right? So if you are using exceptions and you know why, and you know what are the trade-off and you prefer exceptions, good for you. That's great. Same if you want to use monads, right? So make your own experiments, make your own ideas, and don't listen to random people at conferences or meetups, right? Forge your own ideas. If you have one idea to take away from this talk, it's not monad, it's not exceptions, it's that one, because it applies to everything. So now is the time to wrap up. If you want to drill down a little bit more, here are a few resources. So normally, Tinel will share a link with everything. You don't have to do a screenshot or whatever, because I have everything in a public storage with the extract of the talk itself and all of that in a file. So I have a few books, a few blog posts, a few repos, etc., etc. And well, thank you, all of you, for attending. I hope you had a good time. I know it's a long one. I know it's dense one. So if you have any question, let me know in the chat. And please share your feedbacks. I would really appreciate. So, yeah. Thank you, Adrian. I appreciate.
Thank you very much, Guillaume.
I'll stop sharing for a minute.
Yeah, I'm going to share the open feedback link for those of you that have a feedback to give, or yeah, a written feedback, or just click on those boxes. You can do it here, and yeah, if you have questions, shoot here or shoot over there on that feedback field, and we'll try to answer you.
I see a question from Simon. So if you have multiple failure cases, well, I would reply with a question. Can you, let's say you have one success and two failures. Would those failures be of the same type or different types? Because then the answer will be different. Of course. In that case, there is a monad I didn't talk about. It was on one of the slides. It's called the one-off. So it's the equivalent of the discriminated unions in Fsharp, and it's basically like either, like either left or right, but with more than two options. So you can literally have a monad with 10 possible outcomes, right? It's good, but the thing is, we're in C#. It can be quite lengthy if you start to write like that. So you have another solution that might be of different types, but you can put them under the same interface for whatever reason. It's what I do on my end. Because something I didn't mention, LanguageX is probably my favorite library ever, right? But I'm not using it on my SDK for specific reasons, mainly because monads are part of my public API, and I don't want to make people depend on that, because I don't have any control over it. So I made my own, right? So what I do is actually I focused on mainly one, which is either success or failure. But failure is basically I result failure. And then I have different types that are underneath. So I can regroup them under the same branch if you want. That's one way of doing it. I hope it does answer your question. If you really want to have different types, you have to go with the one-off. You need more than 2 options. Adrian, get and save. Yeah, I agree. It's kind of difficult because you cannot make everyone happy all the time. So it was a way for me to make sure that people that wanted to have a functional approach could do that, and someone who doesn't care about it can do its own way as well. So it's one more method than usual if you want to just have an exception being thrown. But yeah. Ilya, are you also using Fsharp in your day-to-day job? That's a very good question, and the answer is no. I'm using that only on pet projects. And this is something I would love to do more, but then you end up with the problem about the market itself. Let's say tomorrow you are given all the keys to start a new project. Do you start in Fsharp knowing that? For me, for example, I only have limited experience on it from pet projects, no professional experience. Am I confident enough to start a new project with that? How do I hire a team knowing that it's very rare to find Fsharp developers? I would love to, but you have to take all that in consideration. So if you are like confident enough, I'd say do so, but you have to be careful about the context. Do you have an idea of the cost implementing that in a legacy project? Well, the cost, I can't tell anything because it doesn't matter about, it matters about the size of the project. But actually, my SDK is kind of a legacy project. And at the moment, what I'm doing is everything new follows the Monads way, if you want. And at the moment, I have plenty of legacy, or at least previous endpoints that are still showing tons of exceptions. And my goal is to replace them over time. But the problem is, every time I want to replace something, it becomes a breaking change for my customers. So I have to be very, very careful with that. If you are on a legacy project that only you use and that is not exposed to the outside, it's much easier. You can break things without impacting hundreds of thousands of customers. So, yeah. So Simon, the way I'm thinking about exceptions are kind of breaking the written type system that even untyped languages are now using. Yeah, I agree with that. But then, I mean, I'm not trying to portray exception as, evil incarnate. They have pros, they are cons, and as I said, for me the cons outweigh the benefits. But they are still like widely used, and you see them everywhere. So they are here. But I agree with you, especially in the, for example, in the, like you mentioned here, when you talk about validation, there is no need to throw an exception when you have an invalid user input. It's literally overkill. So then you have exceptions for your database, your API, or your architecture layers, or your middlewares. You can't do anything with that. But I mean, what you can do is not throw them manually. So yeah. I don't know if there are other questions. Feel free to shoot. And if you want to look at that on a legacy project, look at mine. It's open source. You can take a look at it.
Yeah, and it's legacy because you had to move from one level of your SDK to another one.
Yeah, that's difficult.
That's basically
because
the perfect example done by the master.
Yeah, the biggest problem for me is I can't change everything I want. Because if I introduce breaking change for someone and they just, for example, upgrade their package and suddenly I break the entire code base, I don't want to do that. And so I have to go step by step. And when I do a breaking change, I have to introduce an upgrade documentation, because I need to tell people what to do to mitigate all the problems that comes from the breaking change. It's suddenly a lot of work. So it's very difficult to touch existing stuff. But if you're working on a project that is internally for your customers and not exposed to the outside to other developers, it's much, much easier to do that.
Are there any more questions? Doesn't seem like it. I'll start by stopping the recording, but thank you very much, guys, for joining. Thank you very
Suddenly,
much.
I got a new title,
Yeah.
Your Honor.
Thank you very much, everyone. Was great. Thank you, Guillaume, for presenting this talk.
Well, thank you for the invitation. I hope people are happy with it and learned something. I had a really good time, and thank you for the question and the feedback. I really appreciate.
Yeah, by the way, I think I still have the open feedback over here. If you haven't left feedback yet, please do so. I'm gonna stop the recording now. Thank you, guys.